Imagine looking up at the night sky filled with countless stars stretching across the darkness. The universe is vast, and with so many stars and planets out there, it seems likely that there could be other life forms, just like us, wondering the same thing. Yet, despite the size of the universe and the possibility of life elsewhere, we have found no evidence of it. This is the mystery at the heart of the Fermi paradox, a question that asks why, with so many chances for life to exist, we haven't heard from or found any signs of intelligent extraterrestrial beings. The term Fermi paradox was coined in 1950 after an intriguing conversation between physicist Enrico Fermi and his colleagues at the Los Alamos National Laboratory. During a lunch break, Fermi remarked on the apparent contradiction between the high probability of extraterrestrial civilizations existing in the Milky Way galaxy and the complete lack of evidence for or contact with such civilizations. "Where is everybody?" Fermi famously asked, suggesting a question that would come to haunt humanity's search for extraterrestrial life. His paradox has since become a central topic in the study of astrobiology, extraterrestrial intelligence, and the nature of life in the universe. The paradox hinges on a simple premise: if life is a common occurrence in the universe, and given the vast number of stars in our galaxy, many of which have planets in the habitable zone, why has there been no communication or evidence of intelligent extraterrestrial life? Furthermore, why are we not witnessing visits from extraterrestrial civilizations? The chances of at least one of these civilizations having the technology to communicate or travel across the stars seem high, yet the silence persists. The Fermi paradox is deeply connected to the Drake equation, developed in 1961 by the astrophysicist Frank Drake. The equation attempts to estimate the number of active, communicative extraterrestrial civilizations in our galaxy. It factors in variables such as the rate of star formation, the fraction of stars that have planets, the number of planets that could support life, and the likelihood that life evolves into intelligent beings capable of communication. While the equation is useful in providing a framework for thinking about the possibilities, its values are largely speculative. Many of the factors are still unknown, leading to wildly different conclusions about the likelihood of extraterrestrial civilizations. The variability of these estimates is part of the reason why the Fermi paradox remains so perplexing. If we assume that even a small fraction of stars harbor habitable planets, the universe should be teeming with life. Yet the evidence seems to contradict this assumption. There are several potential explanations for why we have not detected extraterrestrial civilizations, ranging from the limits of our technology to the possibility that intelligent civilizations simply do not exist, or are so rare that they are nearly impossible to find. There are several potential explanations for the silence that defines the Fermi paradox, each suggesting a different reason why we haven't detected extraterrestrial civilizations. One possibility is the rare Earth hypothesis, which argues that Earth's ability to support complex life is incredibly rare. It suggests that the specific conditions required for life, such as a stable orbit, a large moon, and a magnetic field, might be so unique that while microbial life may be common, intelligent life capable of advanced technology could be extremely rare. Another theory is the concept of the Great Filter. This idea proposes that at some point in the development of life, there is a crucial bottleneck that makes the emergence of intelligent civilizations exceedingly difficult. The Great Filter could lie in the past, where the evolution of life on Earth was an extraordinary event, or it could be something that all civilizations must face in the future, such as self-destruction through war or ecological collapse. If the Great Filter is ahead of us, it could explain why we haven't encountered other civilizations. They may have all failed to make it through this critical stage. Alternatively, some suggest that the limitations of our technology might be at fault. Perhaps extraterrestrial civilizations are using communication methods that we are not yet capable of detecting. For example, our current efforts to find alien signals, such as searching for radio waves, may be too narrow. Civilizations could be using advanced technology that we don't yet understand, or their signals could be so weak that we haven't yet developed the means to detect them. Then there is the zoo hypothesis, which proposes that extraterrestrials are aware of us but deliberately avoid contact. According to this theory, advanced civilizations might choose to observe humanity from a distance, similar to how zookeepers watch animals without interfering. They may have ethical guidelines that prevent them from interfering with less advanced species, or they could be waiting for us to reach a certain level of development before engaging with us. Another possibility is that intelligent civilizations might tend to destroy themselves before they ever reach the technological capability to communicate with other civilizations. This theory suggests that the development of dangerous technologies, such as nuclear weapons, often leads to the self-destruction of civilizations. If this is common among advanced societies, it would explain why we haven't detected any signs of extraterrestrial life. Most civilizations might have simply destroyed themselves before they could reach out. Finally, some theorists suggest that extraterrestrial civilizations may already be here, but we simply can't perceive them. One idea is that life could have arrived on Earth in microscopic forms, possibly through a process called panspermia, and these life forms might be so different from us that we don't recognize them. Additionally, these civilizations could exist in ways beyond our current understanding of life, perhaps in other dimensions or forms that we can't detect with our present technology. Each of these theories attempts to explain the silence we encounter in our search for extraterrestrial life, but none offer a definitive answer. The Fermi paradox remains one of the greatest mysteries of our time, forcing us to rethink our place in the universe and the possibility of life beyond Earth. As we continue to search for extraterrestrial life, the Fermi paradox pushes us to reconsider not only the existence of other civilizations, but also the nature of intelligence itself. The idea that we might be alone in the vastness of the universe is both awe-inspiring and unsettling. If intelligent civilizations are indeed out there but are undetectable for reasons beyond our current comprehension, it may mean that our understanding of life and communication is still far too limited. We might be at the edge of a breakthrough in technology or discovery that will finally answer this age-old question, or it could mean that the universe is filled with life forms that are simply beyond our capacity to find or understand. Moreover, the paradox raises philosophical questions about our own future. If we truly are one of the few or the only civilization to have reached this point in technological development, it highlights how fragile our existence may be. The prospect of our own self-destruction, whether through war, environmental collapse, or another unknown cause, is a looming threat. The silence from the cosmos could serve as a warning. Civilizations may rise and fall throughout the universe, but perhaps most fail to survive long enough to establish meaningful contact with others. If we are to avoid the fate of these hypothetical civilizations, the key may lie in understanding not only the cosmos, but also how to preserve and nurture our own civilization, long enough to make lasting contact with the stars. The Fermi paradox is not just a question about the existence of extraterrestrial life, it is also a reflection of our place in the universe. The silence we encounter when we look out into the stars could be a reminder of the profound and humbling mystery that surrounds us. It challenges us to confront our assumptions about life, intelligence, and the future of our own civilization. While we may not yet have answers to the Fermi paradox, the search for extraterrestrial life continues to push the boundaries of science and technology. Each new discovery, whether it's a new exoplanet in the habitable zone, a breakthrough in astrobiology, or an advancement in our ability to detect alien signals, brings us one step closer to understanding our place in the cosmos. Perhaps the true answer to the Fermi paradox is not that we are alone, but that the universe is far more mysterious and complex than we could ever imagine. And in that mystery, there may lie answers to questions we have not yet thought to ask.